thinking time. There's always one clever guy who will call out the answer. So as a teaching strategy, I'll say nobody speaks. So everybody's quiet.
He said about 10 times in the last class.
Right.
Yeah.
So,
What is he doing? Why is he yelling?
so I'm going to split them up. Is that clear? So is that u over radical u minus 5 over radical u du? Now this is from the previous lesson. If you remember, I'm going to do something, see this comes back. Is that just u1 half? U1 half. So what's u over u1 half? u1 half. And is that minus 5 u negative 1 half? Yes?
Can you use the
Yeah, sure. Mazu, nobody remembers. I realized this from teaching. Yes, you're right. But nobody remembers. So I'm just going to do it the way kids will do it. Yeah, you're right. But you remember, you do it. Okay. Oh, and sorry for saying shut up. U to the power of 3 halves times 2/3. Careful. Yeah. Minus 5 u to the power of, that's negative 1 half. 1 half times 2. Is that clear? What's your friend? Let's rewrite. So that's 2/3. What was u again? Because we can plug in right here, right? To the power of 3 halves minus 10. Yes? And then x plus 3 to the power of plus 3. Thank you. Okay, I just want to share with you what Ms. Basu was suggesting. She's right, as usual, but she says, look at me, she says, did we not have a radical u here? 2 steps down, back. Did we not have radical u? She says, Rama, why don't we use the formula? Is that not 2 radical u? But I'm going to say something, see if you agree with me, saying, yeah, that's probably true. When you're on your homework, how many of you are actually going to remember that? Are you going to just use the power rule? That's why I did the power rule. Okay. Nobody's going to remember, hey, because Ms. Martin, I'm talking about student psychology. Over here, the first guy, after all, is u1 half. And the second guy is u1 half. Nobody's going to say that's actually radical u. I know that. I'm going to do power rule here, but not here. Can you see? Everybody's going to be on a roll. They'll just say, oh, I'm just going to use the power rule. Yeah. You can do it. All right. Guys, don't write this down. We're writing notes. This is the next set of problems. Here's the challenge for today. We're learning 4 different kinds of problems. Okay, no, it gets even worse. On the homework, they're all jumbled up. So for your own sakes, do your homework. Cypressy, do your homework. Okay, write down what this next set of problems is. It's ax plus b over cx plus d. Okay. So in other words, you have a linear expression on the top and you have a linear expression on the bottom. In simple language, you have a line and a line. Is that clear? Here's a strategy. So in case you're wondering, what's going on, we're just expanding the variety of problems we can deal with. We did one kind of u substitution, but we started with what if you have a radical and a linear. What do we do then? So we use u substitution for that. But what if it's like that? How does u substitution work for that one? So I'm showing you how to do this. First step, you do long division. From your IM3 days. I don't know who you had for IM3, whether you remember doing long division. Well, this is Hillcrest, so nobody remembers. Okay, but anyway, but we're going to do long division. Relax, I'll go with it. Okay, now put your pencils down. So here's what I'm supposed to do. You don't need to write, just watch. Here's what I'm supposed to do. 5x minus 3 divided by 2x minus 1. Why? Can you see that guy goes into that? Both are lines. That guy goes into that. Somebody tell me why that's not very easy to do at all. I'll make it easy for you. Watch. I'll make it easy for you. Is that easy? Do you understand what I'm saying? But if I put a 5 here, is that bloody complicated? Now, I'll tell you a true story. All the textbooks give a certain strategy. And the way to do it is this. This is really what the textbooks say. 2x, I need a 5x. I'm going to write the answer, look and say, oh yeah, I get it. Is that actually 5 halves? Okay? Now the last 3 years, even his brother, whom I taught, we have struggled doing it this way, using fractions. Okay, that's what, and I had to subtract and add fractions. Last year when I was teaching this, I sat down, I was making the lesson plan like today, day 56 of last year. Oh, is it today 55? Yeah. 55. I was planning the lesson, I said, man, my kids hate this fraction thing. That's the only thing books give. There must be a better, more efficient way to do it. And I came up with it. What's this? This is elegance. This is sheer genius. What's this? Okay, play along. We will find the LCM of 5 and 2. In simple language, give me a small number that 2 and 5 go into. So what's this? I will make the 5x a 10x. Play along. So if I want a 10x, am I multiplying by 2? But I should balance with a 2. Here, is everybody okay so far? Observe magic happening. So is that 1/2 integral? That's in parentheses, yeah? So in the top it is 10x minus over, and does 10 go 2 into 10? Problem solved. Simple issue. We can now divide. No fractions anymore. Okay? So we have 10x minus 6. I'm going to do long division. 2x minus 5. Now many of you will have forgotten this. Relax, I'm going to walk you through it. I need a 10x, I have a 2x. 5. Now in case you forgot, I'm going to distribute. What's 5 times 2x? What's 5 times negative 5? Now I don't know if you remember your division. You should switch the sign because you're subtracting, right? What's negative 6 plus 25? 19. And in case you vaguely remember, that's called the remainder, right? And that's the quotient. I'm going to write this. So I've done the division. I'm going to write this in a slightly different way than you used to teach it in IM3. See if you vaguely remember this. So that problem, oh, I forgot the dx. So that problem is really this. 1/2 integral. The answer is 5 plus 19 over 2x minus 5 dx. How many of you vaguely remember that? Like writing it like a weird way. Okay. So again, the answer quotient plus the remainder over the divisor. Oh! That's very easy to integrate. Watch. 1/2, big brackets. Look down. I'm walking you through it. What's the integral of 5? 5x. Careful. We have a linear expression at the bottom. So what's the integral of 19 over 2x minus 5? 19 ln 2x minus 5 over the 2. Yeah, don't kill the 2. It's okay. This guy will kill you. Okay, divide by the derivative. Oh, watch how elegant this was. Everybody, look at me. Look at me. We didn't even have to do U sub. All the other textbooks did crazy U sub. We did it elegantly without even using U sub. So just to make sure everybody gets it, look at me. When do we use this? We have the same linear expression. Exactly that. First step, long division, but use my trick. But relax. Since I pretend to be a good teacher, we'll do another problem for practice. Write down number 7. So I just created this document in Google Docs in the morning. So I get up at like 4:35 and prepare a lesson.
Real quick.
Just real quick. But surprisingly enough, I spent a lot of time preparing for my IM3 class, my algebra 2 class. I love those kids.
Yeah.
Yeah.
You don't love them?
They're okay. I spend, no, I'm serious. I'm talking about like mental energies. I devote so much mental energy to my algebra 2 class, IM3 class. Okay, if you understood the previous one, what should I do first then? What's the number that 3 and 4 go into? 12. So I should multiply the top by 4 and balance with a 1/4. So rewrite it. So it's 1/4 integral 12x minus all over 4x plus 1 dx. Okay, problem solved. Okay, do long division yourselves. Go on. So it's 12x minus 8, 4x plus 1. 4 goes into 12 how many times? 3. Careful. Switch signs. What's your remainder really?
3 minus 11.
11? Negative 11, right? So I'm going to rewrite the problem. See if you're okay with it. Girls writing good notes. 1/4 bracket. Big bracket. Because the 1/4 applies to everything. A common error students make is they apply the 1/4 only to the first term. No, it's 1/4 times everything. If you remember the pattern of the last problem, what am I writing? 3. I usually tend to write it this way: plus -11 over 4x plus 1. So you don't make mistakes. dx. I'm making a mistake. Is that integral? Okay, finish the problem yourself. Look down. Look down. Finish the problem. 1/4 bracket. Continue. 3x minus 11 ln 4x plus 1 over the 4, right? How many of you clever kids directly write -11 fourths? How many of you do that? That's very smart. Just directly write -11 fourths. So not bad at all. Before I move on, because I'm teaching you 4 different concepts, put your pencils down. So I want to do a review. Look at me. Look at me. So the previous set of problems, I want to make sure learning happens and you're making connections. Look at the board. So the earlier problems we did had radicals in them. I'm speaking, so look at the board, please. So we did u equals x minus 4, u equals x plus 3. We did 2 things. We solved for x and replaced those x with that u. Okay. For that problem, we distribute. Is that clear? For this one, we split it up. And the answer shows up. Yes? And then for these problems, when you have linear on top, linear on the bottom, adjust for the LCM wise and then do long division. Is that clear? Okay, now the big lesson is we're going to do inverse trig. Okay, we're doing integrals of sine inverse and involving sine inverse, tan inverse. Stay with me, do not fall behind. Put this in a box, we're making a formula sheet. See if this comes back from chapter 2. Integral of 1 over 1 plus monkey square. The monkey is, thank you, tan inverse monkey. And integral of 1 over radical 1 minus monkey square. Sine inverse monkey. So, Ms. Joffrey, so monkey is my stand-in for any expression. So I'll say f of monkey. So even when I teach at UCLA, when I teach calculus, I'll say, what's the slope of sine monkey? Kids, I socialize them very quickly. They'll say, oh, I get it, cos monkey. Because they'll ditto the first time, because I've never seen it, never heard it before. I'll say, yeah, guys, do it this way. Guys, do it this way. Say, yeah, I like this. I understand the logic of his doing. Okay, so guys, here's the first step. Look at me, look at me. So we're going to do problems, and I'm telling you they're fairly complicated. With sine inverse and tan inverse. They won't be simple problems. There'll be lots of steps. You need to watch the algebra carefully. But please, the first step, write this down, those of you writing good notes. The first step is always, write the formula. You must write the formula before you start the problem. As in the sine inverse formula, the tan inverse formula. Okay, when you do a problem, you'll see what's going on. What is the value of that? Okay, copy down 8, please. Oh, Ms. Rios and Ms. Marshall will tell you these questions, good news, bad news, depending on your perspective, pretty much appear as MCQs. Why is that a bad news? Because you have only 2 minutes and 20 seconds to solve this. From start to finish, you have 2 minutes and 20 seconds. That's it. They do not almost ever come in FRQs. So you should be very quick on your homework. So I'm assigning 27 problems for homework. I've already prepared the homework. 27 times 2 is 54 minutes. Rounding 60 minutes. Is that clear? So it's time for 60 minutes. Okay, let's start. What formula does this guy remind you of? Tan inverse, write the formula. Integral 1 over 1 plus monkey square, the monkey, equals tan inverse monkey. Do that. Okay, now stop. Let me show you why I'm writing the formula. Doesn't the formula say I should have a 1 in front and the variable at the back? I need to do that here. So rewrite. Oh, by the way, change this, make this a 6 here. Make that a 6. So we're going to do a slightly more complicated problem. So should I pull out a 6? So I'm rewriting it. Is everybody okay there? Why? Because I'm making my expression look closer to that guy. Is that clear? My goal is to make this guy look like that. Now I'm going to say something profound. I'm speaking so little on the board. If I compare this guy with the formula, nobody speaks, so raise your hand when you figure it out. It's not a trick question, it's a simple question. If I'm comparing this guy with that guy, what's monkey? What? I didn't say what's monkey squared. I said what's monkey? Say that loudly. 3x. Does everybody write why 3x? Because 3x squared will give you the 9x squared I need. Does everybody understand that? If write it down for the first time and only time. If monkey squared is 9x squared, is monkey basically 3x? We use u as the monkey always. I'm going to do u sub. Play along. I'm going to do u sub. Use the monkey. Make a note. U is the monkey. You're writing good notes. So u is 3x. Let's wrap it up. Therefore, du equals 3dx. But I only have a dx. So introduce a balance with a 1/3. So the number outside becomes 2. Integral. What is 3x? What is 3dx? Oh, I forgot to write this here. Oh, 3dx here. Is that just du? Over 1 plus, guys, 3x is u. So 9x squared becomes u squared. Look at the magic. Look at the magic. Isn't this guy that guy? You see? So is the answer just tan inverse u then? But what was u?
3x.
There you go. Final answer, 2 tan inverse 3x plus c.
Wow.
So observe the algebra. So the big idea you're learning is u is the monkey. Okay? For the students who will take a little more time, look at me. I'm helping you. The square root of that guy is u. The square root of that guy is always u. Is that clear? Let's do a slightly different problem. Stay with me, do not fall behind. Copy down number 10, please. Copy down number 10. This is a much harder problem than the previous one. So pay close attention. I'm teaching poorly, so pay closer attention. Let's change this slightly. Let's make this like 10 on the top. Okay, let's make it 10 on the top. Okay, nobody speaks. If you're paying attention to notes, what 2 things should I do together? Write the formula, what else? Take out a 10. That 10 should happen mechanically. Take out a 10. Okay, stop. Write the formula. Does that obviously remind you of tan inverse? Okay. 1 over 1 plus monkey squared. D monkey is tan inverse monkey. Is everybody okay there? Okay, now compare. According to the formula, I'm speaking, so look at the board. Should I not have a constant in the front and the variable in the back? Okay, that is the case. I need to make sure, otherwise I'll rewrite it. Is that clear? The constant should be in the front, so I'm okay there. Now I have a problem. Doesn't the formula have a 1 in the front?
Yeah.
So here's the profound thing. The 4 should somehow vanish and a 1 should appear. Because otherwise the tan inverse formula doesn't work. Now let me show you the algebra to introduce a 1. Watch. I'll just factor out the 4. What's this? 4 parentheses. Then what should appear here? 1. Can you see the logic? Plus 25x squared. Nobody speaks. But if I write 25x squared, am I not introducing 100 then? What arithmetic operation should I do so I get the 25? Divide by 4. Always. Second, 4 times that, the 4 will cancel. Observe that algebra step, please. Now look carefully. Is there a 1 on top? Is there a 4 on the bottom? Miss Wynn, actually do this. Isn't that kind of like the 1/4 then? Can I pull it out? Okay, observe the algebra. I can just pull out that 1/4. So it really becomes 10 over 4 integral dx over 1 plus 25x squared over 4. Put your pencils down so I can talk about something. Put your pencils down. Do they match up now? We did all that to match up. Because I must have a 1 and a variable there. Watch. I said this 2 minutes ago. I'll say it again. Monkey is the square root of that. So what's the square root of that? 5x over? That's what u will be. Is that right? Play along. So u is 5x over 2. Therefore du is 5 over 2 dx. Yes? Therefore, I don't have a 1 dx. I need a 5 halves dx. So what should I do? Introduce a 5 halves. What? Use a different pen. Girls, if you're writing good notes, use a different pen. So I should balance it outside with a 2 over 5. So the outside guy is really 1. Okay, that vanished. And now look carefully. What's 5 halves dx? du, and is that just 1 plus u squared? Because 5x over 2 squared is 25x over. Okay, no, stop. Let me show you a shortcut. Put your pencils down so you can see the shortcut. Every single time, look at this. In the other class, kids were like ecstatic when I showed them the shortcut. Every single time, when you do the u substitution correctly and balance, after the balancing, this is the expression always. Look at the previous problem. See what happened. No, look at the previous problem. Look down in your notes. When we did the u substitution, isn't that what we always want? That will always be the case. So you don't need, look at me. Here's what you don't have to do. So the 5 halves dx is, I get a du. And then 1 plus, no, directly like this. This will always be the case. Because we balance it correctly. If we balance it because that's where we're going, it will always turn out to be the case. Think about it. It will always be the case. So we're wrapping it up. Is that just tan inverse u? And what is u after all? 5x over 2 plus. That was your 5 halves. Guys, I'm warning you, the algebra is a lot of steps. Put your pencils down so I'm going to go over the algebra for this problem. So, first step, I wrote down the formula. Is that clear? I pulled out the 10. That should happen mechanically. I pulled out the 10. Next step, I observe I need a 1 there and the variable there. I have a 4. So I pull out the 4. But to balance, that's 1 plus, should I divide by 4? That will always happen. And I pull out that 4. Okay, I'm a bad teacher. I will do another example. I was going to go into sine inverse, so I'll do another example. But I'm right here. Okay, because learning doesn't happen until you see patterns. But I'm going to show you a shortcut. So write this down. I'm just going to create an example. Write down 12 over 16 plus 25x squared dx. Okay, let's do this together. And I'll show you lots of shortcuts. This is much faster than it actually looks like. What formula does this guy resemble? So integral 1 over 1 plus monkey squared d monkey equals tan inverse monkey. Yes? Okay. Tell me a couple of things I can do. Pull out the 12. Okay, now stop. I'm showing you a shortcut. So you're going to be faster. Remember, 2 minutes and 20 seconds. If you look here, he's writing. Am I pulling out the 4? Will the 4 migrate outside? Can I do that directly? So can I write 12 over 16 directly? I'm showing you shortcuts. Oh, we timed ourselves in the other class. We did one problem in like 75 seconds. Remember, 2 minutes 20 on the AEP exam. And you say, how can I do all of that? No, I showed them shortcuts. So watch. The 16 will go there. Integral 1 over 1 plus 25x squared over 16. You see that? dx. What is u? 5 over 4x. Therefore, du equals 5 over 4 dx. Everybody okay so far? Therefore, introduce a 5 over 4. Balance with a 4 over 5. Now observe my shortcut. 4 goes 4 times, 4 goes 3 times. So is that 3/5? Now, stop. Am I ready to do u substitution? And my trick is, when you're doing this u substitution, is that stupid expression always. So integral 1 over 1 plus u squared du. You don't even need to think. It will always work itself out. Babar, wake up. Let's wrap it up. 3/5 tan inverse u. And what is u after all? Plus 6. That's your answer. Not too bad. Observe the shortcut. So you can kind of skip a step in your mind, but make sure your algebra is right. Okay, let's do a sine inverse problem. Stay with me, please. Copy down 12. Oh, let's make it interesting. Let's put a 20 here. So what 2 things should I do first step? Pull out the 20 and write the formula, which is integral 1 over radical. Okay. So should I pull out a 20? Okay, now I'm going to introduce some algebraic manipulation now and show you some shortcuts. I'm speaking sort of the board. I need a 1. I have the 1. So am I good to go? As usual, like in the previous problem. What's the monkey? 5x. Very good. So u is 5x. Therefore du is 5 dx. Is that clear? Okay, integral dx over radical 1 minus 25x squared. Therefore, the top is 5, but balanced with a 5 outside. So the number outside is really 4. At this stage, look at the shortcut. Is that obviously sine inverse? Don't even think. It'll always work out. Because have a look. 5 dx is du. It'll always work out. And let's wrap it up. 4 sine inverse.
5x.
Thank you. U, which is 5x plus c. Okay. Okay. Now I'm going to raise the difficulty level. Okay. This is where in the US we would say shit just got real. Okay. Right on 13 please. So to address Ms. Burtle's concerns, am I allowed to say it? No. Actually change this, make this a 16. I want to do a lot of 25s. Make that a 16. And then make that an 8 on the top. Now pay very close attention. I want to teach you a similar shortcut that I taught for the tab. But a similar shortcut. Play along. Is that 8 outside? Don't write this yet. Okay. Actually I can. Integral radical 1 minus monkey squared. The monkey is sine inverse monkey. Okay, now look at the board. That number should really be 1. So like in the tan problem, should I factor out the 16? Now play along, I'll teach you a shortcut in just a second. So inside becomes 1 minus x squared over 16. Same concept, yes? Oh! Isn't the 16 underneath the radical? When it comes out of the radical, what will it become?
4.
So I'm going to do this as a shortcut, see if you can play along with the next question and say, okay, I get it. Yes? Skipping all those steps. I don't need to show all those steps. Again, there's no wrong. Pull out the 16, square root of 16, 4. Integral dx over radical 1 minus x squared over 16. Is that clear? So from now on, everybody, for the next problem, I will expect us to do this directly. Is that clear? Alright. As before, u is x over 4. du equals 1/4 dx. What should I introduce? 1/4. Therefore, balance with a 4. So the number outside is really, look down.
8.
Integral. Oh, stop. Are we doing u substitution? Can I just skip the step and just write down d over radical 1 times u squared? So absolute final answer, 8 sine inverse x over. So I have a thing in my class, as you observe, I have these Ramaswamisms that I say for every class. Look down, nobody looks at the board. Because I'm kind of fostering independence rather than kids copying off the board.
Yeah.
Okay. 14 is as difficult as it gets, guys. 14 is as difficult. If you understand 14, you pretty much have understood any problem. Let's put a negative 12 on top. Oh, let's have fun with this problem. We'll time ourselves. Okay. We will start at 15. All right. At 15 is. I hope you copied on the problems. Okay. Start. Should we write the formula? 1 over radical. We won't be in a rush. Monkey squared, d monkey. I'm deliberately slowing down. I'm even talking. I shouldn't be talking. I should be focusing on the problem. What can I pull out? Negative 12 over 5. How many of you understand why the 5? The square root of 25 is 5. It gets pulled out. Observe the pattern. Integral dx over radical 1 minus 4x squared over 25. Are you able to follow that? Are you able to follow that? Okay, can we do u sub now? U is, hint, it's always the square root of that monkey guy. 2x over 5. Therefore, du equals 2/5 dx. Introduce a 2/5. Balance with a 5/2. So the outside number is really negative 6. At this stage, are we doing u sub? We are short circuited. So therefore, du over radical 1 minus u squared. Final answer, negative 6 over, negative 6 sine 2x over 5. exactly 1 minute and 15 seconds. We just took 1 minute and 15 seconds. Okay, I'm giving you study time. Take 2 minutes, look over these examples. How to balance tan inverse and sine inverse. I just have one more last concept to do. Then we're done. Just one more. Please don't skip too many steps. Some of you, guys, the steps I skipped are good enough. Cycle C, don't come up with like I can go directly. Don't overdo it. I hope I'm making sense. I'm almost certain there'll be one or two bright kids on the homework. You'll say, I can just go from here to here. It's very likely you'll skip small numbers here and there and say, oh my god, I should have shown that step. Okay, you're better off. If you want to skip, just skip that many steps. I'm skipping the maximum number without making mistakes. So don't forget Miss Hanson. So square root of 25 comes out, which is 5, and that becomes 4x squared over split over 25, because we're dividing the balance. Okay, the last concept, I promise you 4 concepts. The last concept is this. Draw a line, please. Draw a line. This is the easiest of the law. This is the easiest of the law. You have a simple linear expression on top, and you have variations. You have, say, bx squared plus, or b squared x squared plus c squared dx. Or you have ax radical, b squared x squared. Oh, you can have a minus here too. It doesn't matter. Plus or minus c squared dx. You may not have a radical at all. Ax over b squared x squared plus or minus c squared dx. So as long as you have a quadratic like that and you have a constant, just a constant x. Look at the board to see how easy it is. Let's make a guess. Make a guess. U should be b squared x squared plus or minus c squared. U should be, and the answer is just magically sure. You don't even have to think too hard. U is b squared x squared plus or minus c squared. Always. The answer is just magically sure. So observe the pattern. It's not on the board. I'm going to make the problem up. So you have a quadratic on the bottom, but you have a simple linear constant on the top. Okay. So let's do, what example are we at? Are we even writing anything or just randomly doing something? Okay. Guys, penultimo problema del día. Okay, the last but 2 problems of the day. Let's put a negative 4x. Radical 16x squared plus 25. Okay. I'm going to try to confuse you. I want you to resist being confused. I'm going to, okay, this guy is either a sine inverse problem or a tan inverse problem. Oh, why not? Oh, why is this not a tan inverse problem? This is a radical. Why is this not a sine inverse problem? Louder? There's a plus sign? Okay, what's this? I want to make sure you understand. I'll remove the radical. So everybody remove the radical. Again, I apologize for it. Remove the radical. What was that again? 16x squared plus 25. Okay, let's see who's crazy brilliant. I'm going to try to confuse you still. That's a tan inverse problem. Why not? Miss Dawn. There's an x on top. Do you understand that? The tan inverse has a constant on the bottom, and you have x squared plus monkey squared, whatever. Is everybody okay there? This is it. But watch. Is that very seductive? You're tempted to say tan inverse, right? But you have an x on top, so watch out. So our trick is this. When you have a simple linear constant on top with an x, and you have like that, just use u substitution. Let's do this. So u equals 16x squared plus 25. Oh! Should I pull out the negative 4 actually? Let's do that. Therefore, du equals... guys, there'll be only an x on top, yeah? Is that 32x dx? Nice! So I need a balance of the 1 over 32. You see how elegant it is. Therefore, the expression really becomes negative 1 over 8 integral du over u. Is everybody okay there? And what's integral of 1 over u? ln u. But what is u after all?
16x squared.
ln 16x squared plus 1. Okay. We'll do one more for practice. So guys, do you observe? you have a square in the radical or underneath, but you have a simple term outside. Then just do U substitution. You'll be tempted to do sine inverse, tan inverse, but they won't work. Okay. All right. La último problema do día. Write on integral 16. What are we talking about? 16. Say negative 12x over radical. Say 9 minus 25x squared. Again, nobody speaks. I'm going to try to confuse you. Doesn't that look like sine inverse? Well, you're correct. Why not? There's an x on top. So should I just pull out the negative 12 first step? Always. Should I just use U sub? Therefore, U is 9 minus 25x squared. Therefore, du equals negative 50x dx. Therefore, introduce a balance with a 1 over negative 50. So the outside number is 6 over 25. Is that just du over radical u? I'm going to use Marshall's rule. Who remembers the formula for 1 over radical u? 2 radical u. And what is u after all? What? Oh my God, Ashley, 2 goes 6 times, 2 goes 25 times. Is everybody okay there? All right. 9 minus 25x squared is actually 12, correct? 6 times 2. And we are D. All right, thank you. Sorry? Oh, down the street, not yours, man. Okay, it's small enough that you're really tired. But that's far away in Van Buren. I'm just going to reverse that time. Unless you bring me some Thai food from home. Guys. Shh. Some of you, guys, shh. Now it's my fault, but I've been emphasizing the homework. Guys, some of you are forgetting to time yourselves. You must, it's not an option. You must time yourself. Just remember, it's like Bayes' thing. You do this mechanically, everybody must time their homework. Is that clear? It shouldn't last you more than an hour, but I need to see. Don't make up a number. Just say, okay, the Rama, this fool is just bugging me. Here's 45 minutes. Yeah, happy. No. Actually time yourself. Okay, thank you. Sorry? You're right. I can do all but how many people do you know? Yeah, thank you.